Yes, you can hear me, right? Hello. Yeah, thank you, Shraddha. Shraddha and Shravanti. Okay. So, yeah, before starting the session, yes, I want to talk to you people. Okay. So, I understand every day we are having a session in the afternoon. I know it's very difficult to attend a session in the afternoon, but we don't have any choice. Okay. So, and one more thing, actually, I'm facing one, not a kind of a problem and situation. It's like here there are people from all the departments. Yes. Uh, I hope there are people from CSC, ECE, Triple E, and EIE. Okay. And yes or no? Any other branches other than CSC, ECE, Triple E, EIE? Okay. So, are there anyone from civil or mechanical? I don't think so. As for my information, no one from civil and mechanical are attending the session. Yes. Okay. So I can tell actually that is a kind of advantage because all of you almost have same knowledge. Okay. So now if you observe here, the problem is there are people from CSC. Okay. So which are from technical background, and there are people from other branches, non-technical background. Okay. So the main problem is actually I'm not I'm telling or not. Okay. So for example, it's like if I saw a question. Okay. Some people are directly giving me the answers. Yes, you might have come across those particular questions. Okay. So the main thing is, as some of you are giving answers, actually I'm getting confused. Should I discuss a particular question in detail, or I just need to tell the logic? Okay. So in case, then why you should waste time again listening to that particular question, right? So in that case, what will I do? I'll display some other question. Okay. So that you can practice that question. In the meantime, I complete this particular whatever the question which was there in the schedule. Yes. The main thing is I'll be following the schedule. Okay. So, but whenever I'm discussing any particular question, if you have already solved that question, okay. So if you already know the logic for that particular question, please tell me. Please send it. Please send a message. Okay. So and I hope only I can see your messages. Your friends cannot see your messages, so need not to worry. Okay. So don't think like what other people will think about me. No, all those worries are not there. So that's why whenever I display any particular question, okay. So if you have already solved that particular question, then please send me a message in the chat so that I'll display a question. You take a screenshot and start working on that particular question. Okay. So if you have any doubts regarding the questions which I am showing to you, okay. So we can discuss after this end of this class. Okay. So shall we follow this? Yes, mainly people from CSC branches, I hope. Okay, so even if people from EC, Triple E, AE also, if you have already solved these questions, whatever I am going to discuss, okay. So please tell me, don't waste your time. Okay, so please tell me so that I'll give you another question and we can practice that question. Yes or no? Can we do this? Yes, is it okay? Please respond. Okay, and yeah, Srijan Shraddha, yes, okay. Yes, we'll do this thing. And one more thing, whenever I understand that today is Saturday, tomorrow is a weekend. Okay, I know that in the afternoon session you might be having any plans for tomorrow. Yes, I understand, but we don't have any chance. Okay, so I think yesterday and today you have taken mock Vita test, right, of Codevita. I hope you understood what was the difficulty level. Yes, okay. And one more, and also, okay. So and one more thing from Monday onwards, we are planning assessments also for you. Okay. So today I'll give you one link to practice. Okay. So you can practice those questions. So since we have been 1 week, I did not give you any practice test questions and we did not conduct any assessment. Actually, we should do it. Okay. So because of some technical issues, we could not. So from today, okay. So what we'll do, I'll give you one link to practice questions, and also from Monday, okay, you'll be having assessments. Okay. Whenever you have an assessment, I'll tell you one day before. Okay, so that you can prepare actually. And assessment, please take in the morning. Yes. Okay. So I'll tell you. And one more thing. Now itself, I'm telling assessments. will not be on the topics which we are discussing at present. Okay, so assessment will be a full Codevita. Okay, so why we have planned that? Because we have less time. I hope everyone knows August 9th is the first round. Okay, if you only practice questions on some particular topics, it may not help you. So that's why what we thought is like it will be better if we conduct mock test on total syllabus or total topics. Okay, so I know there will be some questions which we have not discussed. You try on your own. If you are not getting, yes, we'll be learning in the class. However, okay, so such that at least you'll be having some questions to think or to get a logic on your own. Yes. Is it fine to conduct a test on total topic? Yes or no? Please respond. Yes. Okay. So yeah, thank you. Why we are doing this? Because you'll understand. Okay. So you'll have an idea how the test will be actually, how the mock vita test, Codevita test will be there. Okay. So I hope don't worry, you'll get credentials everything. Okay. So mostly on Monday you'll be having a test. Okay. And today before leaving the class, I'll give you the link. Okay, so to practice. Okay, so I'm also creating some questions for you to practice. Okay, so that will be in hacker rank. I hope everyone have an hacker rank ID. Yes. Okay, so I'll give a link, you can practice there. Okay, so if not, please create. Okay, so and one more thing, what I'm observing is like almost after the half of this class, okay, so some of you people are leaving. I understand session is for 3 hours. I know it is very difficult. Okay. So whenever you people are feeling bored, okay. So whenever you people feel that you already know those questions, okay. So okay. So please tell me. I'll give you some questions to practice. Yes, practice those questions. If you have any doubts, please ask me. Okay. So if you cannot ask me in the middle, after this session, yeah, whoever, whatever the questions I gave, we can discuss logics for those questions also. No worries. Yes, sir. Okay. So this is what I wanted to talk. Okay. And one more thing, if you have any suggestions or if you have any problems, okay. So if you want to give any feedback, please tell now. Okay. So if not, we'll start the session. Yes. If you want to speak anything, yes, you can unmute your audio and then speak. Okay. Or if you want to send any message or if you want to give any suggestions, yes, I'm open to it. So accordingly, we'll plan the sessions. Yes. And yeah, and one more thing is like definitely we cannot shift the sessions to the morning. Okay, so it should happen only in the afternoon. Okay, fast itself I'm telling. Okay, so if you have anything to talk or if you have anything to give suggestions, please tell me. Okay, so if not, we'll start discussing questions. Okay, and one more thing, actually on the second day itself we should discuss algorithms and complexity. Okay, so on that day I could not discuss because you people are interested to solve questions. Okay, so and one more thing, algorithms and complexity is very important. Okay, so I cannot skip that particular topic. Okay, so today definitely we'll discuss, but on one more thing, I'll not get you bored. Okay, so because we will be discussing some questions and also some algorithms. Yes, and that two algorithms we are not discussing in detail. Okay, in detail problems we'll discuss again later in the later sessions. Okay, so but you should know how to find it complexity at least. So if I want to discuss about the complexity, I should give introduction to algorithms. Yeah, excuse me. Yes, we'll see those things. Okay, and again I am telling. So if you have any problems regarding the session, please talk to me. Okay, so anything, so whatever you want to tell, please tell me. And one more thing, if you already know the question which I am discussing, please tell me, please send a text message. Okay, sir, please give another question, or I know this question, whatever it is. Okay, so I'll display the question and then you can start practicing that question. You need not to waste time. Okay, fine, let it be. I'm not getting any responses, so I'm proceeding to the session now. Okay, 1 minute, excuse me. Yeah. uh, yes. First question, please try this question. I hope everyone can see the question, right? I hope screen is visible. If it is not visible, please tell me. Please talk, respond. Okay. So that is, I am asking you to respond because it is not actually uh, uh, as we are discussing online. I don't know. I cannot read your minds, or I cannot uh, check what is happening. Yeah, 1 minute. Someone has just sent a message. I am unable to check. Yeah, fine. Now, if you know this question, please tell me. I'll give you another question. Don't waste your time just uh, solving the questions which you already know. Yeah, thank you, Fani Kumar. And one more thing, whenever I ask questions, please respond, because I'll not understand whether you are understanding or not. If it is a normal class, at least by your faces, at least by your expressions, I could guess something. Now it is not possible. Yes. Shall we? Yeah. Please read the question. Okay. So let me read it for you. Consider the first three natural numbers 1, 2, 3. Excuse me. These can be arranged in the following ways: 2, 3, 1, 1, 3, 2. Okay. In both of these arrangements, the number increased to a certain point and then decrease. A sequence with this property is called a mountain peak sequence. Okay. Okay. So yeah, main thing is mountain peak sequence. We'll discuss what is this mountain peak sequence. Fine. Given an integer n, write a program to find the remainder of mountain peak arrangements. Okay. So that can be obtained by rearranging the numbers 1, 2, and so on up to n. Okay. So input format is one line containing the integer n. Output format will be an integer giving the remainder of the number of mountain peak arrangements that could be obtained from 1, 2, and so on n. Okay. So yeah, and one more thing to remember. Okay. So and one more thing is yeah, 1 minute. I'll make it this in one line. Yeah. So if you observe, question is fine. Okay. And one more thing to remember is n is divided by mod. Okay. And they gave mod value. Mod value is 10 to the power of 9 plus 7. And they gave some condition for n value. They gave some input. N is equal to 3. Output should be 2. N is equal to 4. Output should be 6. Okay. So first we'll try to understand the question. Okay. So what is the question? They gave some condition. They gave some condition for this mountain peak sequence. Okay, so what is that? They'll give you n value. Okay, so for that n value, you should find how many mountain peak sequences or how many mountain peak sequences can be formed. Yes, that is the main thing. How many mountain peak sequences can be formed by using a given number. Okay, so first input they gave 3. First we'll see what is a mountain peak sequence. Okay, so generally if we take any mountain, will be in this fashion, right? Okay, so it will be increasing and then decreasing. Okay, so if you observe, yeah, so that clarity we can get it here. So they gave input as 1, 2, 3. Yes, they gave input as 1, 2, 3. So I'm taking n is equal to 3. So if n is equal to 3, if there are 3 numbers, can anyone tell me in how many ways I can arrange these 3 numbers? Yes, any answers? In how many ways I can arrange these 3 numbers? Someone is telling 8. Please check. In how many ways I can arrange n numbers? Someone is telling 9 ways. Okay, 8, 9. Can you tell me what are those 8 and 9 ways? And one more thing, numbers should not repeat it. No repetition. Actually, this is an aptitude question. I hope uh, I find fine. If n is equal to 3, in how many ways I can arrange? Okay, exactly, Srija. In 3 factorial ways we can arrange, which is nothing but 6. So I hope you know n numbers can be arranged in n factorial ways. Yes. So totally, these 3 numbers can be arranged in 3 factorial ways. So that is nothing but totally 6 numbers. Okay. So can anyone tell me what are those 6 ways of arranging these 3 numbers? Yes. Okay. So I'm going to write all those 6 ways. 1, 2, 3. Okay. So 2, 1, 3, 3, 1, 2. Okay. 1, 3, 2, 2, 3, 1. Yeah, thank you, Srija. Okay, 2, 3, 1, and 3, 2, 1. So these are the 6 different ways of arranging these 3 numbers. Okay, so these are the 6 different ways. So in these 6, they are telling only 2 numbers are there, which are of mountain peak arrangements. Okay, so what are those numbers? So what are those things? So only 2, 3, 1 and 1, 3, 2. We'll see. Okay, why only these are called as so for example, I'm taking another ink. Okay, so 2, 3, 1 and 1, 3, 2. Yeah, so only 2, 3, 1 and 1, 3, 2 are telling these can be arranged in the following ways: 2, 3, 1 and 1, 3, 2. In both of these arrangements, the number increase to a certain extent, a certain point, and then decrease. Yeah, see. So this is what is mountain peak sequence is. What should happen? The number should increase to a certain point and then decrease. So only those are called as mountain peak sequences. Okay. So can I tell this is the mountain peak sequence? No. Why? Because here the numbers are only increasing. So if you observe 1, 2, 3, 1, 2, 3, but it should increase and then decrease. So this cannot be my mountain peak sequence. And again, 2, 1, 3. So here it should increase and then decrease, but it is decreasing and then increasing. Even this cannot be my mountain peak sequence. Okay. Next, 3, 1, 2. So it is only decreasing. Okay. So sorry, decreasing and then increasing. 3, 1, 2. Even this cannot be my mountain peak sequence. Coming to 1, 3, 2. Yes, 1, 3, 2. Yes, it is to a certain point increasing and then decreasing. This is possible. That is what they have given. Next, 2, 3, 1. Yes, from 2 to 3 increase, from 3 to 1 decrease. Okay. So even this is did you understand why only these two are given in the question? Here only if I take n is equal to 3, only 2 are possible. What are those? 1, 3, 2 and 2, 3, 1. Okay. So everyone understood this question? Yes or no? So yes, please respond. Understood or not? Yeah. Okay. So now let us take one more case. So they gave one more case as 4. Okay. So I hope for n is equal to 3, everyone understood. Let us take one more case. Okay. So 1 minute. Yeah. So if I take n is equal to 4. Okay. So if I take n is equal to 4, how many ways are possible totally? So if I take n is equal to 4, so totally 4 factorial ways. So what is 4 factorial? 24 numbers are possible. Yes, Shruti, thank you. Okay. So I'll quickly write all those 24 numbers and then we'll see how many cases. Our output should be 6. Okay. So let us check what if the logic we are thinking is correct or not. Okay. So 1, 2, 3, 4. Okay. 2, 1, 3, 4. 3, 1, 2, 4. 4, 1, 2, 3. Okay. Next. 1, 2, 4, 3. So please check if I'm repeating any numbers. Okay. Whenever I'm writing, please check if I'm repeating any numbers or if I'm repeating any series. All the series or all the numbers should be different. 4, 1, 3, 2. Okay. So 1 3 2 4. I'll try to write as fast as possible. 3 2 1 4 4 2 1 3. 1 3 4 2 2 3 4 1 3 2 4 1 4 2 3 1 1 4 2 3 2 4 1 3 3 4 1 2 4 3 1 2. Okay, one minute. 4 3 1 2. Next four more numbers. 1 4 3 2 2 4 3 1 3 4 2 1 4 3 2 1. Okay, give me 1 minute. I'll try to arrange and then we'll check. So I have written all the numbers. So guys, please tell me. Okay. Uh, yeah, guys, please tell me what are the numbers. Okay. So yeah, Shraddha, you have given the logic. Okay. So please tell me which numbers have this mountain peak arrangements. So there should be totally 6 numbers. Yes. So can you people tell me what are those 6 numbers where we have this mountain peak arrangement? Yes. Guys, I've written all the numbers. Please check and tell me which 6 numbers have those mountain peak arrangements. According to the question, I should get only 6 numbers. Okay. So 1, 2, 3, 4, 5, 6 rows I have written. Okay. There are 4 numbers, so totally 24 numbers are possible. So guys, please tell me what are those 6 numbers? Yes. Any answers? Uh, yes. Okay. So yeah, we'll see. Yeah, Shruti. Okay. So we'll check. We'll check all those numbers. Yes, thank you, Shraddha, Shruti. Yes, people, thank you for responding. Nandini Kumari. Yeah. So coming to obviously 1, 2, 3, 4. So it is only increasing. This cannot be my number. Okay. So 2, 1, 3, 4. From 2 to 1 increasing, from 3 to 4. No. So it is actually what? Decreasing, increasing, and so on. So it is no. This cannot be my mountain peak arrangement. Okay. So as people are giving answers, let me check only those numbers. Why to waste time checking all those numbers? Okay. So yeah. So 2 1 4 3 2 3 1 2 4 not possible. 4 1 2 3. Okay. And one more thing. So if you observe, if you see any number which is starting at, so if you observe in 1 2 3 4, maximum number is 4. So if a number is starting with the maximum number, it cannot be of increasing and decreasing. So I can tell all these numbers are not possible. Yes or no? If I have a maximum number at the beginning or at the ending, so even this one, this cannot be mountain peak. This cannot be mountain peak. Yes. If a maximum number is at the beginning or ending, so obviously that cannot be my mountain peak arrangements, because it should be increasing and then decreasing. Yes. Okay. So 1 2 4 3. Yeah. So increasing and then decreasing possible. Okay. So 2 1 4 3. So decreased again, not possible. Decreased, increased, not possible. Okay. So 3 1 4 2, not possible. Yes. Okay. And then 2 3 1 4, increased, decreased. 3 2 1 4, 1 in middle, not possible. Okay. So 1 3 4 2. Yeah. So 1 3 4 2 is possible. Okay. So because increased and then decreased. So 2 3 4 1, from 2 to 3, 3 to 4, 4 to 1, possible. Yes. 3 2 4 1, possible. Okay. So if 3 to 4 1 is possible, so from 3, no. 3 to 2 decreased and then increased, decreased and increased, not possible. 1 4 2 3, 1 to 4 increased, 4 to 2 decreased and then increased, not possible. 1 4 to 3, not possible. 2 4 1, obviously not possible. Okay. So 3 4 1 2, 3 to 4 increased and then decreased and then increased, not possible. Yes. 1 4 3 2, increased, decreased. Yes. 2 4 3 1, 2 4 3 1. Yes. Okay. So 2 to 4 increased and then decreased. Okay. So 3, 4, 2, 3 to 4 increased and then decreased. Yes. Only 6 arrangements are possible. These are the 6 arrangements. 1, 2, 3, 4, 5, 6. Yes. So yeah, these are those 6 arrangements. Yeah. Okay. So if you observe when n is equal to 3. Okay. So if I try to represent all these numbers. Okay. If I try to check all these numbers. Okay, I'm clearing. I hope you understood why, how are those 6 arrangements. Okay. So I'm clearing all these things. Okay. So 1 minute. So it is like when n is equal to 3. Okay. So when n is equal to 3, I got 2 arrangements. When n is equal to 4. When n is equal to 4, I got 6 arrangements. When n is equal to 5. Okay. Yeah. When n is equal to 5 or when n is equal to 6. Okay. So you'll get 30 arrangements. When n is equal to 5. Can anyone tell me when n is equal to 5, how many arrangements are possible? Yeah. So when n is equal to 5, 14 arrangements are possible. Shruti is telling 24 to the TD student would work. Okay, let me check. Okay, so try to check, do we have any relation in all these numbers? Okay, so try to check, do we have any relation? Yes. Any relation is possible with all these numbers? Yes. When n is equal to 3, 2 arrangements. When n is equal to 4, 4 arrangements. When n is equal to 5, 14 arrangements. Do we have any relation between all these numbers? Try to check. For n is equal to 3, okay, 1 minute. Yeah, 530 is giving some relation 2 plus 2 square, 2 plus 2 power 2. Okay, check, is it possible for all the numbers? Yeah. Some people are giving 2 plus 530. 530 is telling 2 plus 2 square, 2 plus 2, 2 square. Okay, so 2 plus 2 square will work for n is equal to 4. Okay, so what about remaining numbers? So can you tell me why you have taken 2 plus 2 square only? So what are the logic you are using that should work for all the numbers? Yes. Okay. So try to check. 3, 2, 4, 6, 5, 14, 6 and 30. Okay. So 6 and 30. So if you observe these numbers, 2, 6, 14, 32. Okay. So yeah. So 14, 36, 2. So if you observe, actually these are numbers related to 2 power something. Okay. So for example, if I take 2 power 1, 2, 2 per 4 will be 16, but I have here 8 only. When n is equal to 6. Okay. So if I go with 2 per 6, for example, okay. So what is 2 per 6? 2 per 6 is around 64 something, somewhere you are getting around 64, right? Okay. Yeah. So 2 per 5 is 32, 2 per 6 is 64. So if I go with all these numbers, so if you observe all these numbers, okay. So I'm trying to get some pattern. Okay. So if I go with 2 per 6, 64, no, it is actually half of this number. 2 per 5, 2 per 5 is 32, 14. Yeah. So if you observe, actually these numbers are somewhere near to 2 per 5. Okay. So observe whatever I'm trying to write, observe. Okay. Uh, these numbers are somewhere near to these. Unable to find this thing. Okay. 2 square. So if you observe 2 per 5 is 32. Okay. Somewhere near 2 per 4 is 16, 14. 2 per 3 is 8. Okay. So 2 square is 4. Okay. So if you observe in all these numbers, it is always minus 2. Yes. Actually, these are numbers somewhere related to 2 power only. You can actually guess 30, 14, 6, 2. Okay. So obviously addition logic is not possible because numbers are varying. There is a large difference in all these numbers. Okay. Not obvious subtraction, multiplication. Okay. Obviously there should be ratio of multiplication. So I'm going with 2 power. Okay. So if you observe all these numbers, when n is equal to 6, 2 power 5 is 32, 32 minus 2 is 30. When n is equal to 5, 2 power 4, 2 power 4 is how much? 2 power 4 is 16, 16 minus 2, 14. When n is equal to 4, 2 cube 8, 8 minus 2, 6. When n is equal to 3, 2 square minus 2 is 2. Yeah, yeah, Samati, that is what I was actually trying to tell. 2 plus 2 square, 6 plus 2 cube, 14 plus 2 power 4. Okay. I understood. I understood. Now I understood something. What the logic are telling? Okay. So you're telling previous number plus. Yeah, I understood. Yes. Okay. Yeah. So the problem, Shravanti is giving this logic. Okay. 1 minute. Let me check. I did not check the chart session. Okay. So Shravanti is giving us this logic. Okay. So we'll see what is the problem with this logic. Okay. Sorry, it is not 16. It is 6. I'll see all the logics. Don't worry. Okay. So we'll discuss. So 2 square, 2 power 2 cube, which is equal to 14. Or here it should be 6 plus previous number. Next, 14 plus 2 power 4, which is equal to 30. Yes. So this is when n is equal to 4. This is when n is equal to 5. This is when n is equal to 6. I understand. Okay. So this is the logic one of your friend is giving. Okay. So can anyone tell me what is the yeah, this will give us the answer. Yes, obviously this will give us the answer n value, but here number of steps, actually time complexity is increasing. So that is why actually I was telling we should discuss time complexity. Okay, fine. After this question, we'll discuss time complexity thing. Okay. So here I can tell this will take more time than this logic. Can anyone tell me why? Why this logic will take more time than this logic? So if I take this as 1 and this as 2, one will take more time than the previous one will take more time than the two. Okay. So can anyone tell me why? For example, if I want to find when n is equal to 10, yes, what I want ninth value. Yes, exactly, that is what I was about to tell, because we need previous answer. It takes previous values into consideration. Yes. Okay. So for example, if I want to find n is equal to 10, I need to find 9, 8, 7, 6, 5, 4, 3, 2, 1, and then find 10. Okay. So here it will take a lot of time. Okay. So yes, even this logic work, but whenever we try to write any logic, okay, so we'll always write the logic which takes less time. Yes, yes, good Shravanti. That will also work, but it will take more time. Okay, so almost same thing with 530 also. Even 530 gave the same logic. Okay, yeah, Nandini Kumar is telling all the numbers are divided by 2. Yes, okay. And then Shruti is telling when n is equal to 3, 3 factorial. Okay, 1 minute. I'm trying to understand what your friend is trying to tell. Okay. When n is equal to 3, n minus 1 factorial peaks, and same goes for n factorial also. And n is equal to 4, 4 factorial is how much? 4 factorial is 24, but there are not 24 elements, right? 4, 3 minus 1. Okay. So this I can write 3 minus 1 factorial 2. Fine, this is working. So here 4 minus 1 factorial. 4 minus 1 factorial is how much? 3 factorial. Yeah, that is also working for n is equal to 4. When n is equal to 5, 5 minus 1 factorial. Okay, 4 factorial is 24. Okay, but I'm getting only 4. So this logic won't work. Yeah, fine. Same thing, Shruti. Yes, I hope everyone understood the logic. Okay, so what I'm going to do? So I'm going to actually implement this thing. Okay, so and yeah, one more thing. So if you observe here, one more thing. Whenever I have these numbers, so when n is equal to 3, I should go with 2 square minus 2. Yes, when n is equal to 4, 2 cube minus 2. When n is equal to 5, 2 power 4 minus 2. When n is equal to 6, 2 power 5 minus 2. Thank you, Shruti. That is what I was going to tell. So it should be what? 2 power n minus 1, because n is equal to 3, I took 2. N is equal to 4, I took 3. N is equal to 5, I took 4. N is equal to 6, I took 5. 2 power n minus 1 minus 2. Okay. So this is what the logic will be going to implement. Yes. Okay. So what is the logic? 2 power n minus 1. So if I want to write that in programming, so obviously I should. Okay. So I should use power, all those things. Okay. For now, I am writing this thing. 2 power n minus 1. Whatever the value you're getting from this, you should subtract 2. Okay. Uh, this is the logic. Okay, fine. We got the logic. Everything is fine. And one more thing. Do we have any terms which you did not understand in the given question? Do you have any numbers or do you have anything which you don't know why they gave that particular sentence in the question? Try to read the question. Actually, you should get one doubt. Okay. So here in this question, do you have any terms? Okay. So which you did not understand, or you don't know why they gave that particular thing? Yes. Everyone, please read the question carefully and tell me. Do you have any terms? Yeah, exactly, Shruti. That is what I was actually expecting from you. Divided by mod. Okay. So if you observe output format, an integer m giving the remainder of the number of mod and peak arrangements that could be obtained from end to end. Up to here it is fine. 2 power n minus 2 is divided by mod and they gave this value. Okay. So why this mod? Yes. Can anyone tell me why did they give this mod? Yes, you'll see these type of things in a lot of questions. Okay, so it is not only for this question. Okay, so that is why we'll discuss this model. So what is this mod? Okay, so actually why did they give some? They are asking the output. Okay, so divided by some number. What is that number? Mod. That mod they give us 10 power 9 plus 7. Okay, so why mod? Why should we divide 10 power 9 plus 7? Actually, they can change this number also, but mostly they prefer 10 power 9 plus 7. Okay, so but if they want, they can change this number also. Okay, so now we'll discuss actually why mod was given in the question. Okay, so actually you'll get these type of questions. Okay, so they might ask you divided by some number. Okay, so for that actually there is a reason. Yes, 1 minute. Can you see the screen? Nandini Kumari, can you see the screen now? Now is it visible? No. Okay, 1 minute. Yeah, I hope it is visible now. Yeah. Okay. 1 minute. 1 minute. Previously I wrote in some notepad. Yeah, this was the one we were using. Okay. So now we'll discuss what is this mode actually. Okay. So generally, if I take processor, okay. So if I take maximum, okay. So if I want to store any value, okay. So what is the maximum value we can store? For example, I want to store some integer value. Maximum integer value. Okay. So what is the maximum integer value which we can store? Okay. So for example, let us take it is of 64-bit processor. Okay. So in 64-bit processor, what is the maximum value we can store? I don't want range. You can just give in terms of 2 power also, no issues. I don't want the range exactly. Okay. So you can just give in terms of 2 power. Yes. So I'll tell you, this is what actually this is related to that mod only. Okay. So exactly Shraddha. Okay. So if it is 64-bit number, okay. So what is the maximum value we can store? Okay. So we can store a value. So if I talk about range, okay. So range generally it will have positive and negative range. Okay. So it will be 2 power. Okay. 1 minute. Yeah, just like for integer maximum for integer value is if I take integer of 2 bytes minus 327682 plus 32767. Okay, so in the same fashion, yeah, uh, is it 2 power 31 minus 1? Yes. Okay, so yeah, we'll get a clarity on this. So for example, first we'll see smaller number. Okay, so char. So if we take a character, okay, so character is of 8 bits. Okay, so character is of 8 bits. So what is the range? Uh, range. Range is minus 128 to plus 127. Okay. So actually, what can I tell? So what is minus 128? Okay. So what is 2 power 8 actually? 2 power 8 is 256. Yes. 2 power 5 is 32. 64. 128. Yes. Yeah. 1 minute. Some people are trying to 1 minute. Yeah. Okay. So if you observe here, what is my range? My range here simply if I want in bits, I can write minus 2 power 7 to plus 2 power 7. Yes. Minus 2 power 7 to plus 2 power 7. Okay. So which is nothing but minus 128 to plus 128 minus 1. Yeah, 2 power 7 minus 1 because 0 is also included. Okay. So in the same way, so if it is of 64 bits, okay. So if it is only 8 bits, I can do minus 2 power 7 to plus 2 power 7 plus 1. Okay. So here in the same fashion, range. So if I want range, what is the maximum number? My maximum number will be minus 2 power. Okay. So 63 to. Okay. So plus. Okay. I'm particularly giving. That's why I gave bits also, number of bits also. Okay. So it depends. So Shraddha is giving the answer when it is of 2 power when integer is of 32 bytes. But as I'm asking for 64 bytes, that's clearly mentioning. Okay. So what is the maximum size? 2 power 63 minus 1, because 0 is also included. Okay. So if I take this number, okay. So in this with this value, okay. So with this range, okay. So I can store integer as long as 9 into 10 power 18. 9 into 10 power 18. So this is the maximum value actually which I can store if I take integer is of 64 bytes, 64 bits. Okay. So this is the maximum positive value which I can store. Okay. So for example, if I'm working with this, if I get some bigger number than this, okay. So if I get some bigger number than this, then what happens? Can I store that particular number? Okay. So let us take some example. Okay. So I'm taking x is equal to 21. Okay. So now I need to find 21 factorial. Okay. So now I need to find 21 factorial. Okay. So actually 21 factorial is a very big number. Okay. So 21 factorial is a very big number. So this will be around of 5 into 10 power 9. Not 10 power 9, actually 10 power 90. Okay. So if I want a value 21 factorial, maximum range is of this only 9 to 10 power 18. But 21 factorial is of 5 into 10 power 19. So can I store this number? Yes. Can I store this number? If I try to store this in integer variable, will it show any error? Okay. So actually, what is the maximum value? If you take any integer, if you want to store maximum value, what we can do? Okay. So whenever, yeah. So we can use modifiers long int. Okay. So if we are sure that you are only storing positive values, you can also make it as unsigned long int. Okay. So yeah. Okay. So in the first class, I told the concept called modifiers. Okay. So yeah. Now we'll give a clarity why we. So can anyone tell me why did I make here my variable as an unsigned? Anyone from CSC? I'm expecting answers at least from CSC people. If you are there, if you are alive. Okay. Please give answers. Okay. So why did I make my variable as an unsigned? Okay. So don't give me answer to store only positive numbers. Okay. So yeah, I expected. Okay. So I expected because so one more thing. So if I don't make an integer, if I don't make a variable as an unsigned, I can store both positive and negative. So normally I can store both positive and negative. Okay. So but if I make an unsigned, if I make my variable as an unsigned, I can store only positive numbers. So without this, if I can store both positive and negative, then what is the advantage of making a variable as an unsigned and storing only positive numbers? I hope you understood my doubt. Yes, normally I can store both positive and negative. But by making a variable as an unsigned, I can only store positive. If I can store, then what is the advantage? So why we need to make a variable as an unsigned? For positive numbers, reduce size. Can you please explain it clearly? I could not get. Okay. So actually, I've told this in the first class. Okay. So size modifiers. Okay, we have two types. Short and long. This is actually very easy. So whenever you make a variable as a long, 2 bytes extra will be added. Okay. So coming to sign modifiers. Okay. So sign modifiers, we have signed and unsigned. Okay. So we have signed and unsigned. And one more thing, remember in default. So if you observe here, I am not mentioning whether it is signed or unsigned. Why? Generally for any data type, excuse me, for any data type, we will not mention any modifiers because in default, it is taken as a signed. Okay. So that is why we can store both positive and negative. So for example, if I declare a character variable, so if I write char a, yes, this is also equal to, yes, this is also equal to signed char a, signed char a, both the same. Okay, so yeah, so let us take this simple example. Uh, Signed char a, what is my range? My range is minus 128 to plus 127. If I make char a, signed char a, both the same only. In default, it is taken as unsigned, signed character. Okay. So now I'm making my variable as unsigned, unsigned char a. Can anyone tell me what is the range of this unsigned char a? Or let us take char b only. What is the range of this unsigned char? Exactly, Sija. Okay. So the range of this unsigned char is 0 to 255. That is why we'll make a variable as an unsigned. Okay. So if you observe, almost here totally 266 value you can store. Sorry, 256 value. Okay. So because you can store both positive and negative, whatever the range you have, it is divided to minus 128 plus 127. If you make a variable as an unsigned, okay. So if you make a variable as an unsigned, you will not be storing any negative values. So obviously your range increases. So previously it was only 127, but now I can store a positive value of 255. Okay. So this is happening because of MSB. Okay, that concept we'll discuss later. Fine. So what is the use of making a variable as an unsigned? Because almost your size gets doubled, 127 to 255. Okay, so that is why if I want to store any, if I want to check the positive value which I can store, then you can find out. You can make a variable as an unsigned long int. Okay, maximum will be writing long for 2 times. Okay, so this is the maximum value which you can store an integer value. So that depends again on the processor. If it is 32-bit processor, it will be 32, 64, and so on. Okay, so the same thing. So now the problem is, if I take a 64-bit, if I want to get the maximum value, I need to declare it like this. So unsigned long int some a. Okay, so even in this, the maximum value I can store is 9 into 10 power 18, but I want to store 21 factorial. Okay, so I want to store 21 factorial, it will be 5 into 10 power 19. First thing. Okay, so if I write for example, I have declared here a variable, right, unsigned long int a. So now I am writing a is equal to 21 factorial. Okay, I'm finding and I'm storing the value. Look, let me write. Okay, so a is equal to 5 into 10 power 9. Sorry, 10 power 19. Okay, so if I store a bigger value, will it show any error? Yes, anyone tell me? So my range is only up to, actually maximum value I can store is 10 power 18. But here I'm storing a value of 10 power 19. Will it show any error? Yes. Will it show any error? Any answers? So just take this value only, character. Okay. Yeah, Shravanti, it might show this error called into overflow error. That is we discussed in the first class. Okay. So generally, okay. So if I try to store in the character be some 300 value. Okay, so it might show you error called overflow, or generally what it does. Okay, so generally it round off some value and give, it will not give. Okay, so if I take this, yeah, generally if you store a bigger number, okay, so it might show error called overflow, or sometimes what happens. Okay, so it will show warning. Okay, so overflow warning, and then normally if I take C language in normal compilers, it will not show any error, but it will give you some random value, or actually that happens because of the cycling. Okay, so if you store some bigger value, you will not, it will not show any error. Okay, so but okay, 1 minute, I'll explain. I know you're getting confused. Okay, So let me write. Yeah. Okay. So 1 minute. So integer character, I am telling maximum is 0 to 255. Okay. So for example, if I'm making character some c is equal to 300. Okay. So it will not show error. Okay. So but so if I take this as 0. Okay. So and 255. Maximum number is 255. So for example, if I try to store 256. Okay. So instead of 256, it will store 0. If I store 257, instead of 257, it will store 1. If I store 258, okay. So if I try to store 258, instead of 258, it will take. So generally, it will go in this fashion. So it will not rise an error. Okay. So but in TCS, it might rise an error. Okay, because the compiler, right, we can fix whatever you do. But in TCS, we'll get an error called into overflow error. Okay. So but in normal compilers you'll not get any error. Okay. So in normal compilers what happens, so once if you're crossing the range, so actually it is 0 to 255 only. This is 0, this is 255. If I try to store 256 value, okay, so it will take next one 257, one more value, 258, one more value. Okay. So it will go in the cyclic fashion. Okay. So it will not store 300, but it will store some value between this range only, 0 to 255. Okay. So whatever it is happening, whatever may be the cyclic value it is taking. Okay. So you don't worry, whatever it is taking, but will not get the exact value, right? Okay. So we should get 300, but will it give us 300? No, it will give you some random number between 0 to 255. Why? Because of this property. Okay. So actually this is I can tell rounding off or truncation. The value gets truncated. Okay. So yeah, the same thing might happen here. Okay. So the same thing might happen here also. Normally this is what happens. So for example, if I try to store a value which is of 2 power 19, 10 power 19. Okay. So it might do two operations. One is what? Showing into overflow error. Generally in TCS, it will show into overflow error. Okay. So yeah, if not, what it does, it will give you some value between this range only, whatever the range of that particular number. Okay. So those two things might happen. So whatever is happening, actually, we are not getting the exact value. Yes, we will not get the correct output. So in these cases, okay, so these mod value comes into picture. So it is like whenever you are working with bigger values. Okay, so whenever you are working with a value which cannot be represented by using a particular processor. Okay, so then what happens? So then they'll give us the question divided by some number. Okay, so what is mod 10 power? They gave mod 10 power 9 plus 7. Okay, so what is mod 10 power 9 plus 7? So if I take mod, so here what will the mod value? The mod value will be 100. How many 8 zeros? 1 2 3 4 5 6 7 8 10 power 10 power. This is 1 2 3 4 5 6 7 8 and then 7. Okay, so this will be the mod value now for this particular question, 10 power 9 plus 7. Okay, so and they are asking divided by this particular number. Okay, so what happens? So and one more thing, if you observe, if you get any value less than this number. Okay, so for example, I'm dividing 2 divided by, okay, so 2 divided by 10 power 9 plus 7. Can anyone tell me what will be the answer? Control V. 2 divided by 10 power 9 plus 7. Obviously my output will be 2. Yes. So if you observe, if you get any number less than this thing, your output will not be affected. Yes or no? But if you get any number greater than this thing, okay. So if you get any number greater than this thing, okay, so then your output will be changed. Yes. So the same thing will be happening here. So here why they gave us here mod 10 power 9 plus 7, because here there is a chance of for these test cases, your output will not be affected. 2 by 10 power 9 plus 7 will be 2 only. 6 by 10 power 9 plus 7 will be 6 only. But in this question, there is a chance of getting a higher value which cannot be stored. Okay. So in the processor, for example, if you take 32-bit processor, may or may not be stored. Okay. So for that cases, for the safer side, what they are asking us to give the output divided by mod. Yes. So as they are asking the output divided by mod, so obviously their expected output also will be whatever may be the answer that you get divided by mod. Okay. So you just need not to worry what is this thing. Actually, why this mod? This mod is because there might be some test cases where you are unable to store the output in the processor, or you are unable to store output in the memory. In that case, what will they do? Okay, so they'll try to reduce, they'll try to get that into the range. Okay, so for that they'll do this, they'll give us this mod. Okay, so in this, I hope now you understood why they gave this mod. Yes. Okay. So they gave us this mod because you might get a value which cannot be stored. Okay. So some bigger value. So they are trying to reduce that bigger value. Okay, such that it will be stored in the processor or it will be stored in the memory. Okay. And one more thing, you might also get it out. Sir, why it is only 10 power 9 plus 7? Why not plus 10 plus 2? All those things. Okay. So for that, actually, I find it out why. Okay. It is because of these two reasons. Okay, so it should be large enough to fit into integer data type. Okay, and one more thing, it should be a prime number. Can anyone tell me why it should be a prime number? Yes, whatever the value which I am dividing, why it should be a prime number? Yes, any answers? uh, why it should be a prime number? This mod value, they can give anything. Here they give 10 power 9 plus 7, but simply they can give 10 power 9 also, but generally they'll go with the prime number because it will be divisible by only two numbers. Okay, so for example, if you get some number which is divisible, then your output may be affected. Okay, so yeah, that is the reason of this mod 10 power 9 plus 7. Okay, so I hope you understood this logic. Okay, so here the question is very simple. So what is that? Just to implement 10 power 9 plus 7. Okay, so now shall we write code for this? Yes, or shall we discuss the next question? So if you can write a code, then we'll go to the next question. Please respond. Should I write a code, or shall we go to the next question? Yes, next question. Fine. So many people are responding next question. Okay, so we'll go to the next one. Yeah, try this question. Yes, try this question. Read the question. So if you have any doubts, please ask. Okay, so some people are telling they already know this question. Okay, I'll give you 1 minute. Give me 1 minute. I'll show another question. You can try that question. Uh, for the people whoever know this question, okay, so please take a screenshot of this. Uh, okay, some people are telling they know the logic of that question. Okay, so if you know that question, then take a screenshot of this. Okay, so try this question. In the meanwhile, we'll discuss that question. Yes, have you taken screenshot? Can I change it? Please respond. Yes. Okay. Please try this question. Don't waste your time. Okay. So in the meantime, we'll discuss that question. Then we'll come to this. Yeah. Fine. Remaining people, we'll see this question now. Yes, let me read the question for you. Identify the logic behind this series 6, 28, 66, 120, 190, 276. 1 minute. The numbers in the series should be used to create a pyramid. The base of the pyramid will be the widest and will start converging towards the top, where there will only be one element. Each successive layer will have one number less than that on the layer below. It. The width of the pyramid is specified by an input parameter n. In other words, there will be n numbers on the bottom of the layer, on the bottom of the pyramid. The pyramid construction rules are as follows: the first number in the series should be at the top of the pyramid. Last n number of the series should be at the bottommost layer of the pyramid, with nth number being the rightmost number of this layer. Numbers less than 5 digits must be padded with zeros to maintain the sanctity of a pyramid when printed. Have a look at the examples below to get a pictorial understanding of what this rule actually is. Okay, so actually there is something missing here. There should be space also. In the actual question, there is a space. So that is missing here. Yeah. So actually we should print a number. Okay. So actually this is a pattern question. This is a pattern question. What they're telling, in the last row there should be n numbers. So if input is 3, there are 3 numbers. The layer above it should be 1 less than the previous number. So here I have 3, here I have 2, here I have 1. So here input is 2. Okay, so here it is 2 and here it is 1. Okay, and yeah, actually this is a very easy question. So if I write in terms of 1 and 2, okay, so leave this first, we'll see the pattern. So first, if you understand the pattern, then we'll come to this logic. So the pattern is like this. So 1, 2, 3, 1. Next 1, 2. Just take 2 and some number 3. Okay. So next 3, 4, 5. Next 1, 4, 5, 6, 7, 8, 9, 10. So actually the pattern is like this. Okay, so if n is equal to 4, in the last 4 numbers, and the above layer it 3 numbers, in the above layer 2 numbers, and at the topmost 1 layer. Okay, and here there is 1 space, here there are 2 spaces, here there are 3 spaces. Okay, so here there will be 2 spaces, here there will be 1 space, here there will be 0 spaces. Okay, and one more thing, what we should do extra thing here, every number should be of 5 digits. Okay, so if you are getting less than 5 digits, then a number should be padded. Okay, so how can I make a number always print 5 digits? Is how can I make a number? How can I do padding? Padding is nothing but adding extra zeros. Okay, so for example, I want a digit of 5 numbers. Okay, so but I have only one number, so now I should do here padding with 4 zeros. So tell me, how can I do it? Is set precision as 5. Okay, precision now, please check. Here it is not a float value, right, to set a precision. So when it is a float, generally we'll make it as a we'll talk about precision. Precision is nothing but number of decimal points. Yes. Okay, so you might have came across this print statement, printf. Okay, so percentile, for example, I'm writing 3D, comma, let us take some n value. Okay, so I'm writing this statement, or I'm writing printf percentile d, comma, x. Okay, so what happens here? So can anyone tell me what will be the output when x is equal to 6, when x is equal to 45, and when x is equal to 345? So this is the statement. print percentile 3D comma x. Okay, so can anyone tell me what will be the output if I write percentile 3D of x? Yes, any answers? Yes, Isha, exactly correct. That is what the output will be. Yeah. Any other people? So what will be the output if I write percentile 3D comma x and x is equal to 6 when x is equal to 45 and when x is equal to 345? Yeah. So exactly my output will be 006 here 045 next here 345. So if I am getting lesser numbers, so those numbers will be padded with zeros. Okay, so that's it. So printing 5 numbers is always very easy. Just write percentile 5D if you want 5 numbers. Yes, that is not a big task. Okay, so and then printing a pattern is also easy. Okay, so you might have solved first in the first row only one number, second row 2 numbers, third row 3 numbers, fourth row 4 numbers, fifth row 5 numbers. So even that logic, I hope everyone knows. Okay, so one extra thing what we should do. So we should just need to print spaces here. Here two spaces, three spaces, two spaces, one space. Okay, so everything is fine. You just this pattern you already know. I hope everyone knows the pattern. Okay, so and everyone knows this pattern and everyone knows how to print zeros. Okay, the only thing you should know, how can I get this particular series? So the series is like what? My series is like so if you observe, okay, so series is like 6, 28, 66, 120, 190, 276. Yes, so this is what the given series is. Okay, so yeah, now if you can get a logic for this series, then your question is done. So try to get a logic for this series. Yes, people. So try to get a logic for this series. I'll just tell the logic and then we'll take a break. After then we'll see another question. Don't worry. Uh, yes, yes. Yes, Shraddha, actually. Okay. So yeah, here what will be the output? Actually, your output will not. If I give x is equal to 6, your output will be space, space, and 6 here. Okay. So 1 minute. Okay. So now I'll write. Yes, yes, Shraddha, actually I forgot. Okay. So it will be 6, 45 and 345, right? The outputs, the inputs which I gave. So first time I should get 3 numbers minimum. 3D is nothing but in the output I should have minimum 3. Okay, so as I have only one number, so remaining will be what? Space, space, and 6. Next number will be space 45. Next number will be 345. Okay, so this will be the output. So here there will be 2 spaces, 6. Here there will be 1 space, 45. Here there will be 345. But I don't want this pattern, but I want the remaining number should be padded with zeros. Yes, Shraddha, actually I forgot. Thank you for helping. Okay, so if I give percentile 3D, I'll get 2 spaces 6, 1 space 45, and then 345. But I don't want this thing. I want what remaining numbers as zeros instead of spaces. If you don't give anything in default, you'll get spaces. But if you want to pad it with zeros, then what we should do? Make it as percentile 03. Okay, so 03D. So here if you write 0, those will be padded with zeros. Yes, Shraddha, any doubt? If you have a doubt, please ask. Thank you. Thank you for raising that doubt. If not, actually, I forgot about it. Yeah. So generally, if you don't give 0, you'll get spaces. But if you want zeros, give 0, 3D. So now tell me, what is the logic for this series? What is the logic for this series? 6, 28, 66, 120, 190. So if you can get a logic, you already know how to print a pattern. You already know how to print a zeros. Everything is done. So just the question is this logic itself. Yes, guys, any doubts, any logics? And one more thing, if you cannot get a logic for this question, obviously you cannot do anything in the exam. So try to improve your problem solving skills. Language, writing a program is the next case. First, you should get a logic. If you cannot get a logic, you cannot do anything. So how can I improve your logic skills? So start uh, practice as many programs as possible. Okay, I know it's kind of shouting. Okay, so because yeah, you people are not responding, so I'm thinking at least if you're sleeping, at least my voice will wake you up. Okay, so numbers are 6, 28, 66, 120, 190, 276 are the numbers. Okay, so whenever you want to find a series, what will you do? So normally we'll try to find difference between all these numbers. Yeah, can anyone tell me what is the difference between these two numbers? Yes, difference between 6 and 28. 28 minus 6, how much? Respond. Okay, so thank you. At least 2 people are responding. 3. Okay, so 22. Please tell me difference between 28 and 66. What's the difference between 28 and 66? Yeah, Shraddha gave a logic. Yes, we'll discuss. Even that logic also will work. Yeah, so tell me the difference between 28 and 66. People. If not, I'll do one thing. I'll open the participants list and I'll ask one by one. If it was a class, it would have been great. Yeah, thank you. Only 3 or 4 people are responding. What about the remaining people? Everyone is sleeping now. Thank you, Soumya, Bindu, 223, 238. Thank you very much. So how much difference is 38? I'm not asking any logic. So tell me difference between all these numbers. 120 and 66. What is the difference? 54. Thank you, Naveen. Next. 120 and 190. What is the difference? 70. Yes. 190 to 276. What is the difference? Who is 175D0? 175D0 will answer now. Yes, sir. How much? 175D0. Are you there? 86. Yeah. And so if you observe, do we have any similarity between these numbers? 22, 38, 54, 70, 86. Any logic? Exactly, Shraddha. What is it? 16. 22, 38 is how much? 16 plus 16. 22 plus 16 gives you 38. 38 plus 16 gives you how much? 54. 54 plus 70 gives you how much? Sorry, 54 plus 16 gives you 70. 70 plus 16 gives you how much? 86. This is the logic. Actually, we can use this logic. We can use n number of logics. Shraddha has given one more logic. Okay, so let me see. What is that logic? Yeah, 3 into 2, 7 into 4, 11, 3, 7, 11, 15, plus 4, plus 4, plus 4. Yes, Shraddha, even that will work. Okay, so I'll write the logic which is given by Shraddha. 3 into 2 is equal to 6. 7 into 4 given by 28. This is 7. Don't get confused. 11 into 6 gives you 66. 15 into 8 gives you 120. So if you observe with all these numbers, difference is 4. 3 plus 4, 7. 7 plus 4, 11. 11 plus 4, 15. And here my number is increased by 2. So from here to here, it is 2. Here it is 4. Here increase by 4. Here increase by 2. And then multiply and then get the number. This is one more logic. Very good, Shraddha. Either you can use this logic or this logic. Anything is possible. Anything you can use. So tell me which one you want to use now. These are the two logics. So whatever the logic you find it easy, you can use it. Okay. So now tell me, should I need to write a program or shall we go to the next question? Okay. We'll do one thing. We'll take a break now. Okay. So we'll take a break. Okay. So now the time is 4:05. We'll meet at 4:20. Yes, and we'll discuss remaining topics. Just take a break. Don't leave. So this is the logic for this question. So if you want, try a program. If not, I'll explain it. Don't worry. Okay. So take a break for 15 minutes and then we'll meet at 4:20. If you have any doubts, please send it in a chat box. Okay, everyone. I hope everyone is back. Yes, shall we start the session? Yes or no, please respond. I know I'm shouting. I'm doing it purposely. So that you'll not sleep. Yeah. Thank you, Funny Kumar, Shraddha. Yes, yes. Okay. So yeah, at the end of this class, I'll give you the link to practice in HackerRank. Okay. So you should wait until the end of this class. Fine. Okay. Fine. Let it be. So we'll do one thing. So there are three more algorithms to discuss. We'll discuss those three algorithms and we'll leave. Is it okay? Yes or no? There are only three algorithms. Yes. If you respond as quickly as possible. Okay. So we'll complete those three algorithms. And whenever we complete, we can leave. Yes. Okay. So yeah. Fine. Next, we'll discuss about greedy algorithm. I hope everyone knows. I hope not. Sorry. I hope you have an idea about greedy algorithm. If you have an idea about greedy algorithm, please unmute your audio and speak. Anyone can speak. Don't worry that it will be right or wrong. Whatever is, it's fine. I just want you people to speak something. That's it. Any idea what is greedy algorithm? So we have in the previous class we have discussed three algorithms. So what are those? Recursive algorithm, divide and conquer algorithm, and then dynamic programming algorithm. Okay. So today we'll discuss three algorithms. If once these algorithms are done, then we'll close the session for today. Okay. Next, fourth one. These are important. Okay. So that's why I cannot skip these three. Okay. So if these are done in the next class, we'll discuss complexity of all these algorithms. Okay. So complexity is important because that too mainly in TCS Codevita because of this TLE error, time limit exceeded error. Okay. So accordingly, you'll come to know what is the wrong, then you can try to change your algorithm based upon the errors you're getting. Okay. Anyone tell me what you know about greedy algorithm? Any examples of greedy algorithm at least? Uh, yes, examples of greedy algorithm. I'll ask who is 17891A0582. 582, please respond. Uh, yeah, any 582. Any examples of greedy algorithm? Bhavani, Bhavani Nanjuti, Naveen C9. Any examples? Sai Rajesh, Divya, Tarun. Yes, Digital's algorithm and traveling salesman, knapsack. Yes, yes, yes. Very good, very good. Okay, so yeah, in all these things, easy thing is traveling salesman. Okay, so I'll take an example of this traveling salesman algorithm, and then we'll try to explain what is this greedy algorithm. Okay, so what will be doing? Why the name is called as greedy algorithm? Because it is like from the options available. Okay, so we'll always be taking a value. Okay, so I will always try to make optimize optimal choice. So for example, okay, so first we'll see what is this traveling salesman problem. Okay, uh, yes, traveling salesman problem is like we'll be having some cities. Okay, so let us take 3 to 4 cities. Okay, so in these cities, yeah, okay, fine. After pointing out the names people are leaving, okay, I'll not point out the names. Don't leave. It's fine. At least you are listening. That is okay for me. Yeah, fine. Traveling salesman. Let us take some cities. Okay, so A, B, C, D, E. Let us take these are the five cities. Let it be. Let us take all these are connected also. Okay, so traveling salesman is like a person will start from a particular city. Let us take it as A. Okay, so a person will start from a city called A, and he will travel all the cities and then will come back to the same city. Okay, so and let us take some distance. Okay, so it is of 10 kilometers. It is of 1 kilometer. Okay, so it is of 3, 5. I'm taking some random numbers. Okay, so yeah, 2, 20, 7, and 8. Okay, so these are the difference between all the cities. Let us take these are the distances between all the cities. Okay, so and you are at city A. Now what you should do, you should visit all the cities. Salesman, what the salesman does, okay, so he'll visit all the cities and then he'll try to sell it. Yes, okay, so you should visit all these cities. Okay, so and then you should come back to the same city. Okay, so now always what should happen, yeah, and then you should find a route such that you are traveling minimum distance. Okay, so you should find a route such that you'll be traveling minimum distance. So then tell me, how will you solve this? Okay, so generally what will you do? So generally, so here if I am at A, I have how many options? I have 10, 1, and 8. Yes, so from here to here it is of 8 kilometers. From here to here it is of 1 kilometer. From here to A to C it is of 1 kilometer. So generally what will you do? So whenever you try to travel, always, okay, so we'll always try to take the route which is of minimum distance. So here if I have multiple options, what I am doing, always this is a very big problem. Okay, so but at this position, okay, so let us take at 1. Okay, so the first time we have 3 options, 10, 1, and 8. Okay, so if you have multiple options available, so I'll always try to select optimal or minimum choice or optimal solution. Okay, so that is what, so first I'll travel from A to E. Okay, so I'll travel from A to E. Okay, so next you'll be at E again. Here you'll try to take minimum the value which is having minimum distance. Okay, so from here I'll go to here. Yes, okay, and again from here, and one more thing, yeah, from here what will you do? Okay, so let as we are discussing at the basics, okay, let me take easier values. Okay, so let me take fine, even this, actually this is the drawback of this algorithm. Fine, first let me take normal value, and then we'll see. First if I come to middle position, I'll be visiting it twice. Okay, 1 minute. So first let us understand, after then we'll try to see what are the advantages, disadvantages, how to overcome all these things. Okay, so let me take this value as 21. Okay, so I am taking some value as 21. Okay, so yes, okay, so I'm not taking that case because actually those are the conditions. Okay, so now for just we are trying to understand the approach. we are trying to understand the greedy algorithm. After then, we'll see what are the disadvantages, how to overcome all those things. First, let us understand. Okay. So I am at A. Now I should choose the one which is having the minimum value always. So I'll choose this one, 8, this route. Okay. So after then, here I have 20 and 7. I cannot go back, right? That is already visited. Okay. So in 20 and 7, what will I do? I'll select this route. Yes. Okay. So after this, from B to E it is of 2, from B to D it is of 5. Okay. So again here 2 and 5, I'll select the minimum one. What is that? E. This from B to E. Okay. So from here, I cannot go to 21 because these are not visited. So from here, I'll minimum distance. Okay. I'll go here and then I'll go here. Yes. So what is the path I'm traveling? A, C, B, E, D. Okay. So whenever you have multiple chances or multiple options available, always you will choose minimum option or minimal solution. Okay. So this is nothing but greedy algorithm. So we'll always try to be greedy, lesser value. Okay. So again, for example, if both are same, that is one case. For example, if you see the previous case, okay. So in some cases, if I go with this greedy algorithm, in some case you might form a loop. Okay. So or you might be visiting a city twice. Without that, it may not be possible. So if I take the previous case, actually all these are the drawbacks. So 1 minute, 1 minute. So previously, initially, what are the values I took? Yeah. So initially, these are the values. These are the values which I took. Okay. So first, I'll be going from here to here. After then, if I take minimum value, I'll be going here. From here, if I take minimum value, I'll be going here. Okay. So from here, if you observe, if I come to A, if you observe, I did not visit C. Okay. So between 10 and 3, the minimum value is 3 only. So if you observe, I'm visiting E for 2 times. Actually, which is not needed. But here, as I went this algorithm, as I went with this greedy algorithm, so there are chances where you will be doing a process repeatedly. So after here, sorry, yeah. So if you observe after E, so yeah. So if I try to choose greedy algorithm here from 2 here I went 5. From here I came here. So if I want to visit C, I should travel 20 kilometers. So sometimes the greedy algorithm, okay, so may give you good results, may not give you good results. Yes. So if you observe here, 20 is the highest number, but after coming here, I don't have any choice. Okay. So instead of choosing this path, okay, so instead of choosing 5, if you have chosen other number here, yes. So instead of choosing 2, okay, if I have chosen 3, okay. So what I'm telling is like, yeah, 1 minute. So if I use grid algorithm here, uh, this may not give you the exact solution always, like minimum solution always. So from here to here, I'll choose minimum this one. Okay. So after this, minimum will be this one. So after this, minimum will be this one. After this, minimum will be this one. Yes. If I use greedy algorithm here, okay. So 20 plus 2 plus 3 plus 5 plus 1. Okay, so it is you need to travel 25, 30, 31. Okay, so if you use greedy algorithm, so but instead of using greedy algorithm, if you think normally, okay, so sorry, 5 plus 1 is giving you 31, right? Okay, so instead of that, actually, what can you do? So I can go from A to E, I can travel. So here, instead of going to B, if I go to D, from A to D, from D to B, from B to C, C to A. Yes. If I travel in this direction, it will give you 10. Sorry, sorry. Okay. So from A to E, 1, from E to D, 3, from D to B, 5, from Y to B, 7, sorry, B2C 7, and then 8. Okay, it will be 8, 8, 16, 16, 22, 23, 28. This will give you around 24 to 25. So if you observe here, greedy algorithm is giving you 31 kilometers. Okay, so but actually the minimum can be of 24 only. Okay, so actually this is, I can tell, greedy drawback of greedy algorithm, that is like uh, sometimes, okay, so choosing the minimum option at a particular stage may not give you the best solution. Okay, so I cannot tell, this is the main drawback of greedy algorithm. Greedy algorithm may or may not give you the best solution. Vinay is asking, we definitely need to travel through all the letters, or we can leave any letter? No, definitely we should travel through all the cities. That is mandatory. Okay, so definitely we should travel through all the cities. That is mandatory. Okay, so the greedy algorithm is, it cannot assure you that this will be the best option. Okay, that is the main drawback of this greedy algorithm. Okay, so actually, what is greedy algorithm? Greedy algorithm is nothing but choosing a minimal option or optimal solution at that particular level. Okay, so that may or may not give you the best solution, but it definitely will give you the solution. It will definitely give you the solution that may or may not be the best one. If you observe here, if I use greedy algorithm, this is not giving me the best solution. If I take these cases of 31, but this will be around 25 to 31. This is less than. But if I use greedy algorithm, this is giving us the 31. Yes. Uh, yeah, that is about this greedy algorithm. Yes, any doubts? Any doubts in this? Okay. So if I try to write it, so now we'll see. Okay. 1 minute. Uh, Sorry, I got some message. Let me check it. It's important. Okay, fine. Let it be. Okay. Uh, yeah. Greedy algorithm. Greedy algorithm is nothing but making locally optimal, or choosing locally optimal solution. Instead of making, choosing or selecting, whatever it is, selecting, making the locally optimal uh, choice choice in each sub problem. I hope you know what is a sub problem. Yes. Okay. uh, Assuming it will give uh, global optimal solution. Greedy algorithm is nothing but choosing locally optimal choice in each sub problem, assuming it will give us globally optimal solution. Yes. Okay. So properties, where can we use this? Okay. So yeah. So coming to these properties. So properties are nothing but where can I use this particular logic? Okay. So first thing, there should be a sub problem. Okay. Optimal substructure. Yes. So it is like, so if you take cities, so the question is totally traveling 5 cities. So that can be divided into traveling each city one time. Yes. So first property is optimal substructure. Actually, I have told you this in detail when I'm discussing about dynamic programming. Yes. And one more thing is greedy choice property. So if you have chance of selecting greedy choice. Okay. So yeah, examples as you have discussed, as you have told. Okay. Traveling salesman problem. I'm writing it as TSP. Okay. So and then job sequencing, scheduling, all the scheduling problems. Okay. So for example, I want to in a particular time, I need to do maximum works. Okay, so in that case, what you'll do? So you'll always try to start with a work first, which is taking less time. Okay, so it is kind of job scheduling or whatever it is. Okay, so this is about greedy algorithm. Greedy algorithm is nothing but choosing locally optimal solution in each sub problem, assuming it will give us globally optimal solution. Okay, next thing. Next one is brute force. Can anyone tell me what is brute force algorithm? It is actually very easy. Brute force algorithm. Yes. Anyone? Any answers for this brute force algorithm? What is brute force algorithm? Yes. Checking each and every possibility. Exactly, Fani Kumar. Okay. So brute force algorithm is okay. So brute force algorithm is nothing but going through all the possibilities. Okay. So it is like when will I be doing this process? For example, if I want to find a best solution. Okay. So if I want to find a best solution, then what will we do? We'll try all the cases and then we'll select for the best one. Okay. So here, yeah, brute force will not be using any shortcuts. Okay. So here will not be using any shortcuts, but mainly on computation, like going for all the possibilities. Okay. So here directly I'm writing in normal words. Okay. So no shortcuts here. Okay, so no shortcuts here, and going through all the possible cases. Okay, so going through all the possible cases. Any example for this brute force? Going through all the possible cases. Okay, so to find the best solution. To find a best solution. Yes. Okay. So I can tell it mainly relies on sheer computing power to try all possibilities until the solution find, or simply I can tell trying all possibilities. Trying all possibilities. Any example for this dynamic programming? Yeah. Example. So for example, if you need to find a password, yes. So if I need to find a 5-digit password, five-digit password. Here we don't have any shortcut, right? So, for example, if they give some numbers called 1, 2, 3, 4, 5. So, what is the normal way? So, searching for all the numbers 1, 2, 3, 4, 5. Okay. So, totally, how many cases are possible? Yes. So, 1, 2, 3, 4, 5. You need to find a five-digit password. So, in the worst case, can you tell me how many tries we should check, or how many possibilities will be there? Only 10 now. 328 is telling 10 possibilities only. Totally, how many possibilities are, how many ways are possible? It's actually 5, or 5 ways are possible. Exactly, Fani Kumar. Okay, so here there can be repetition, right? All the numbers can be 1, 1, 1, 1, 2, 2, 2, 2. Even repetition is allowed. Whenever repetition is allowed, totally how many cases are possible? N power n ways are possible. Yes. So here, this is one example of this brute force algorithm. What is brute force algorithm? Going through all the possible cases to find a best solution. And one more thing. For example, if you already know the best solution for a program, and whenever you're solving by using brute force algorithm, so if you know the best solution, after getting a best solution, actually you can stop it. Okay. So that you can take as an kind of help in this brute force. What is that? If you already know the best solution, okay, so when can we stop the process? So whenever you get that possible case, okay, So for example, if I tell my efficiency maximum, you will be getting a 50%. So whenever you get efficiency as 50%, then you can stop, because that is the best solution you can find and you already got it. Okay. So generally this algorithm will be used when, so this algorithm will be used whenever you try to find out best solution. Okay. So last one, last algorithm. Yes. Backtracking algorithm. Can anyone tell me what is this backtracking algorithm? Any examples? Yes. Any examples for this backtracking algorithm? Yes. Okay. So I'll give you example. Actually, you can find it. Example Sudoku. Okay. So if you want to find a solution for this Sudoku, okay, you can try this backtracking algorithm. Sudoku solver. And also rat maze problem. Okay. So what is backtracking? Even name, it's in the name itself, you can understand what is backtracking algorithm. Yeah. So backtrack algorithm is nothing but here trying to solve a problem. Okay. So for example, if you fail at a particular sub problem, okay. So then what you'll do, you'll undo that process. Okay. So and then you'll proceed. Okay. So for example, let me take this rat maze problem. What is this rat maze problem? Yeah, exactly. N queen problem also kind of. Okay. So even N queen problem, same. It's like first take a step. Okay. So if that step is not giving you the output, then come back and then repeat. Okay. So for example, yeah, rat maze. Okay. I'll explain. Don't worry. So here it is starting. Here it is ending. And all these are blocks. Okay. So here it is a block. That means a rat cannot travel at this particular position. Okay. So let me take, even this is blocked. Okay. So here a rat at the starting position, so it should reach to the end. And here they gave two conditions. What is that condition? It can travel in forward and it can travel only in down. It cannot go in any other direction. No diagonal. Diagonal is not possible. Okay. So and one more thing. Let me take. Sorry. Okay. So yeah, let it be here also. Okay. So now what will I do? So now generally how will you try? For example, here what will I do? I'll try to move forward. Yes, I'll try to move forward. Can I go in the forward direction? No. Then I'll come back. I'll come back here. Okay. And then I'll try to go downwards. Okay. So here again I'll try to go downward. Is it possible for me to go downward? No. So I'll again come back and then I'll try in this direction. Okay. So let us take, I'll try to go forward. Can I go in the forward direction? No, it is again block. So what later I'll come back. So I'm taking a step. Okay. So if I cannot find a solution, I'm coming back. Same here. So I'll try to move forward. No, not possible. Okay. Let us say I'm going straight. Okay. So here also I'm going straight here. Here, am I reaching the end position? No, I'm not getting a solution. Then what will I do? I'll come back. Come back, take another possibility and then check. Okay. So that is what is this backtracking algorithm. So first take a step. Okay. So if that is not working, come back and choose the other option. Okay. The same thing will be doing in n-queen problem also. N-queen problem is nothing but arranging queens in such a way that we'll discuss. Okay. So for now, leave it. Okay. These are the main algorithms. Okay. So do you have any doubt in this? So if you have any doubt, please ask. If you have any doubt in this algorithm, please ask. Yes. Okay. Yeah. And one more thing, I'll give a link. Okay. So I'll give a link to practice the questions. Okay. Everyone note down this link. 1 minute. Let me write it. So this is the link to practice questions to practice questions. Okay. So this you'll be practicing in Hacker Rank. Okay. So and the link is I'm writing it here. If you want, you can take a screenshot. hackerrank.com/VITH/1. Yes, this is the link. You'll be having 5 questions. Practice all those 5 questions today. Okay, and Monday mostly you'll be having assessment. Okay, so we'll see. We'll give information about that assessment also. Yes, I hope everyone got this link. Yes, please pass it to your friends also. Okay, whoever did not attend the session. Okay, so try to pass this link so that even they can practice. Yeah. Okay. And any doubts up to now? So next we have complexity. Fine. Now we'll discuss the next class. Okay. Yes. I'm launching the poll now. Yes, everyone give feedback. If you have any doubts, please ask. If not, you can leave. Thank you. So please practice those questions. Yes, please practice those questions. And if you have any doubt, please ask. You can stay and ask. If not, you can leave. Thank you. Okay. Stravanti, you're asking backtracking algorithm, right? I'll explain. 1 minute. Okay. So coming to his backtracking algorithm, what is actually backtracking algorithm? Here it is like you'll try to solve a problem. Okay. So you'll try to solve a problem. Okay. And if it fails, for example, I'll try to take a step. So yeah, 1 minute. Yeah. So generally, how will we solve Sudoku? So if we take Sudoku, um, I have three rows, right? 1, 2, 3. 1, 2, 3. 1, 2, 3, 1, 2, 3. If so, if I take, I'm just taking a small box. We take this as one box, and this is one more box. Okay, so I hope you know the conditions in Sudoku. Okay, so then the same name cannot repeat. For example, here in this box, okay, I have just took two simple boxes. Okay, this is one box and this is one more box. Okay, so 1 minute. If not, let me take except. Okay, let it be. So, for example, I hope you know the conditions in Sudoku. For example, if one is here in the same row, I cannot get one again. Yes, each and every box should have all the different values from 1 to 9. Each and every row, each and every column cannot have same numbers. And one more thing, each and every box also cannot have same numbers. So yeah, generally what will we do? So we'll try to, at the beginning, we'll try to fill some numbers. For example, here they gave 9 and here they gave some numbers called 8. Okay, so sorry. 1 minute, 1 minute. Okay, I'll take Excel. That will be easy. Or just will take easy examples. So I thought I have explained rat maze problem. I thought I'll explain by using Sudoku, but drawing a Sudoku is a bit difficult. Okay, 1 minute. Yeah. So okay. So it is. So here actually, let us take here some of the blocks are blocked. Blocking all these things. Okay. So 1 minute. So it is starting, it is ending. So this is a maze. Okay. So here, this is a maze. Okay. I should start here. Okay. Rat. And then that should reach this end from here to here. My rat should come from this position to this position. Okay. So let me take, they gave some conditions. Okay. So that means either you can travel in the forward direction or you can travel in the downward direction, whatever, like whatever conditions they give. So from here, what will I do? Okay, for example, here I try to travel downward direction. Can I travel in the downward direction? No, actually. So here I'm trying to make a step that is moving downward. Okay, so here can I move in this direction? Not possible. So what I'm doing, whatever the step I took, I'm undoing it. So I can come back to same position. So do you have any other option of moving here? Yes. So from here to here. Okay. So after that, I'm taking one more step straight forward. Okay. So from here to here, I can travel. Okay. So next, if I again try to take forward step, if I can try to take forward step, here again there is a block, so I cannot travel in the forward direction. Yes. So in that case, this step is not possible. So what I'm doing, so I'm coming back again to the normal. So here I took a step, which is not giving me the answer. So I'm undoing it. So whatever step you take, you're coming back. Okay. So after this, forward I cannot travel. So I'm going down. Okay. So next I'm going down. So here, yeah, you can travel, no problem. Next, again, if I try to move downward direction. Okay. So if I try to move downward direction, again, I cannot move. So, okay. So even if I try to come to this position, I cannot do it. So again, I'll come back. Okay. So next I'm taking forward direction. Fine, you can do it. Next you're taking forward direction. You can possible. Next you're taking forward direction. So if you take forward direction here, you are ending here. Yes. So is it, are you reaching end? No. So whatever the step you take, you took here, it is not giving the answer. So you are undoing it. Yes. So for example, yeah. So if I try to move again in the forward direction, not possible. You're not getting result. So what you can do, you can undo that step. So now I'm undoing. So instead of moving in this direction, I'm moving downward direction. Yes. So I can reach. So it is like take a step. I'm writing it. Okay. Take a step. If it is giving solution or if you are moving towards solution, then you can find. Okay. So take a step. Okay. So if you are moving towards, then okay. Okay. So if we are moving towards solution. Okay. So if we are moving towards solution, it's fine. You can continue. Okay. So you can continue. Okay. So if it fails in giving you the solution, for example, if you have reached a dead end. Okay. For example, here I have reached a dead end here. Okay. So if it fails, okay. So then what will I do? Then I'll undo. Okay. So yeah. Then I'll undo the previous step and then we'll continue. Okay. Then I'll undo the previous step. Okay. And we'll proceed and then we'll continue. We'll continue for the next possible thing. Okay. And then continue and then repeat the same process. Yes, that's what I'll be doing. Take a step. If it is giving you the solution, it's fine. Move forward. If it is not giving you the solution, then undo that process. Okay. So and then try to proceed try to proceed to get the solution. Okay. So this is about backtracking algorithm. Okay. So I hope you have understood. If you have any doubt, please ask. If you did not understand, you can ask me again. I'll explain. No issues. Is it fine? Okay. Thank you very much. Yeah. If you have any doubts, you can ask. If not, you can leave.